Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I will go over the chain rule. And before that, we will take a look at our daily problem. This problem actually asks this. So this is actually double derivative, which is actually the derivative of this function. If we have g of x equal to f prime of x, then this f double prime of x is just equal to g prime of x. And with that being cleared out, you can pause the video if you want to try and proceed the video when you believe you have an answer. So first of all, we have this. So these two. If f of x is a quadratic polynomial, is actually the only thing that we want from f of x, and the rest are just dealing with f prime of x and f double prime of x. And if we have f of x, let's define that as a quadratic polynomial, so ax squared plus bx plus c. We don't need more complicated definition, we just use the standard form. And this f prime of x would be equal to 2ax plus b. And if you notice, that is actually just a linear function. So if we have 2 points, then we can just simply calculate the equation of the linear function. So then we just simply have it's 10 minus 4 over, we have the slope is equal to 10 minus 4 over 5 minus 3. That's 2, that's 6, so get that it's 3. And find the y-intercept, then we have f of 0. F prime of 0 is equal to this, so that's 4 minus 3 times 3, and that is negative 5. And we have our final equation or function, that is f prime of 0. So actually it's f prime of x, and that would be equal to 3x minus 5. Not too bad. Let's plug that back in to see. So if we have that, then we have 9 minus 5 is 4. If we have that, we have 15 minus 5 is 10. So we are correct. And we just need to find this, so the derivative on top of that. So if we want the derivative on top of that, we just have f double prime of x, which is equal to just 3. Actually, you don't even need to find the y-intercept, because you know that's just the slope, and the slope of a linear function would just be the double prime of x. And now let's take a look at the chain rule. The chain rule basically over here wants to take the derivative of this composite function with respect of x. And let's introduce a variant of this notation over here. A variant of this notation over here is actually putting the function on the top. So basically df over dx is actually written this way, so that is the same as dx of f of x. Of course, that is also the same with f prime of x. If you think about it, it makes sense, because on a graph, if you have this f, which is basically the y value on the graph, and this x is basically the x value on the graph, and what's that? Rise over run. That is exactly the definition of slope, or like a similar way of the definition of the slope. And this is obviously what we defined as derivatives. So after going over this notation, we can rewrite this above confusing notation as df over dx times this. So basically this is equivalent to that because it is taking the derivative of f with respect to the innermost, which is x. And let's take an intuitive view about it. You can think of this as basically cancel out this part of the derivative, but that is not one of the properties of derivatives, and we still have to prove that using limits. So we basically have this, and if you want to think of it like this, then these two cancel out, but that's not actually what happens. Let's actually rewrite this. So df over dx is equal to the limit as h approaches 0 of this delta y, basically the change of y. Let's write it as the change of f so that we don't mess it up with our g. So the change of f over the change of x, which is just h in our case, and this is actually the definition of derivatives if you don't recognize it. That is equal to the limit as h approaches 0 of this. So delta f over delta g times delta g over h. And we can use the property of limits to split it up to get this. So we have this. Actually, we have a function of g over here over h. And we know that is simply the definition of limits, so we can simply get that into dg over dx. And for this part, it's actually not directly the definition of limits, because for this part and this part, they're not the same variable. So let's take a look at our assumptions. So we assume that this is differentiable, meaning that both this and this has to be differentiable. If both this and that has to be differentiable, then that means they're continuous. So if we have a graph that's continuous, just find some weird, strange graphs, then if the x value approaches 0, so that approaches 0, then the y value would also approach 0, no matter how drastically the thing changes. Even if the graph looks like this, although we need to make sure it's a function. Even if the graph looks like this, we still would say, because if it's approaching 0, then it's just a point, and that would be approaching 0 as well. So this, we can rewrite this h is approaching 0 to be the y value, which is g is approaching 0, and now that is the definition of derivatives, and that is just simply df over dg. And that is the chain rule proof. Thank you for watching this episode of Investigation, and I will see you in the next video. Peace out.